Now we're going to actually construct a confidence interval for a population proportion. And the method we're going to use requires this. We need both n times p to be greater than 5 and n times q to be greater than 5. And now in this case, n, that's our sample size. And this p, well, it's really going to be p hat. That's going to be our estimated value of the population proportion. So if you're going to use this method, the first thing you want to do is ensure that both n times p and n times q are both bigger than 5. When that happens, when both of them are bigger than 5, then we can use the normal curve to approximate this probability. And you may even recall that the expected value of the mean is n times p. Let me write that so it's readable. N times p, and that sigma, that is the square root of npq. So here's our formula for a confidence interval. It's going to be our estimate plus or minus some maximum error, right? This z-score right here, that is the maximum error of our estimate. So it's the z-value, which depends on our level of confidence, times this square root, pq over n. So that's what we're going to use for our interval. But if we write it in interval form, it would look like this. P hat minus that z critical value score times the square root of pq over n. That's going to be less than p, the true population proportion, which is going to be less than, now same thing on the right side but with a plus. P hat plus z sub c times the square root of pq over n. Let's see how to use this formula. And in our last unit, if you were with us then, we did an example where we did this. We surveyed 1,000 large corporations, and 250 said that they preferred to hire a non-smoker over a smoker. So the first thing we did is we found a point estimate. So a point estimate, p hat was r over n. 250 said that they preferred a non-smoker out of the 1,000 that we surveyed. So the percentage, the true proportion estimate for the true proportion is 0.25. So about 25% of all major corporations prefer non-smoking candidates over smokers. So I'll get us some room here, and I'll just write the p hat is 0.25. Now, if we know p hat, then we know q hat, right? Q hat is going to be 1 minus 0.25, which is 0.75. Maybe we'll need that, maybe not. So now in this section, let's actually do this. Let's construct a 95% confidence interval for the actual proportion, the true proportion, of large corporations that prefer to hire non-smokers over smokers. So let's start by writing our formula. Now, p hat, we know what that is. That is our 0.25. So it's going to be 0.25 plus or minus. Now, what is our z-score here? We're running this at 0.95. All right, so what we need to do is get this. What is z sub c at 0.95? All right, so you may remember that number, but remember what we're doing here. You could always get it, because what we're saying is that you've got 95% of all the area in that region right there. That leaves how much outside? 5%, and if you cut it in half, it's 0.0025. And if you ran an inverse normal on that, you would see that we get negative 1.96, positive 1.96. So let's put in 1.96 times this square root. Now PQ, well P, we'll have to use P hat. That's 0.25 and then 0.75, right? They have to add up to 1, divided by our sample size, which is 1,000. Now to compute this, I'm going to do it straight on my calculator. I'm putting in 1.96, and then you can press times if you want, but you don't need to. Square root, and then put in 0.25 times 0.75, divide by 1,000, right? And the square root follows you over. And then I came out with, or I've still got my 0.25 out here, plus or minus. I got 0.0268, say, 0.0268. Right, now that is the error, right? That's the maximum error of our estimate. So let's subtract and add and write our interval. So let's write this out. It's going to be 0.25 minus that error, 0.0268. That's going to be less than the true proportion, P, less than 0.25 plus 0.0268. And when I did that, I got 0.2232, 0.2232, less than the true proportion, less than 2768, 0.2768. That's the confidence interval. But now we've got that, but here's a big question. We just jumped right into using the formula. What we need to know for sure is, can we really use this formula? We can if we know if, right, n times p is greater than 5 and n times q is greater than 5. Okay, we didn't check it, but we'll check it now. So n was 0.25. No, that's backwards. N is 1,000, and P was 0.25, and N was 1,000. Q was 0.75. So this is 25% of 1,000, which is 250, which is greater than 5, and this is 75% of 1,000, which is 750, which is greater than 5. So yes, we can use the CI formula. So it's probably always a good idea to check first, so you're not wasting your time. Now you may want to use your calculator. After you verify, all right, so the first thing you want to do is verify that n times p is greater than 5, n times q is greater than 5. Then on your calculator, go to Stat, and then scroll down to over to Tests. Okay, then you go over to, scroll over to Tests. All right, so Stat, scroll over to Tests, scroll down to, now you have to go all the way down to A. And A is this. It is a 1 prop proportion Z interval. Now remember, because n times p is greater than 5 and n times q is greater than 5, the binomial distribution is very close to the normal distribution. So that's why we're going to use the Z interval. So you select 1 because it comes up on 1. So select A, all right, so you select A, and then what you see is this. You see X, N, sea level, and then calculate. Calculate. Now, for X, that's going to be, for us, that's going to be 250, right? That's how many we observed. N, 1,000. Our sea level is going to be 95. Now you can put in 95 or 0.95. Either one of them work. I've got to get this in mind. So 1,000. All right, and the confidence level is 95%. And now go down to calculate, and here's what I get. I calculate, I'll do it up here. I got this interval. So it puts it in parentheses, 0.22316, and then 0.27684. All right, so if we wanted to just round off a bit, how about if we did it like this? 0.22 less than the true proportion, less than 0.2, this is 276. How about if I write it as 28? All right, so on my calculator, I've got it now, where it's telling me that the true proportion, I'm 95% sure that the true proportion lies somewhere in this interval, 22% to 28%. And just to note that we are saying that there is a 95% chance that this interval actually contains the true proportion. So we think there's a 95% chance that any number in here could be the true proportion. So if somebody suggests that the true proportion is 33%, well, we could reject that. We could reject that claim because our interval goes from 22 to 28. So we have statistical evidence that this is too high, and we would reject that claim.